All right, here we're on chapter 5 on accumulating change, limits of sums, and the definite integral. This is section 5.3 on accumulation functions, and we're looking at it graphically. So accumulation functions. Well, given a rate of change function for a certain quantity, the accumulation of change in that quantity can be evaluated by using the area of the region between that rate of change curve and the horizontal axis. Now, to do this, adding a grid to the graph of f really makes it a lot easier to estimate the areas of the region under f. So our accumulation function overall of a function f denoted by a of x is equal to the integral from a to x of f of t dt gives the accumulation of the signed area between the horizontal axis and the graph of f from a to x. Now the constant a is the input value at which the accumulation is 0, and the constant a is called our initial input value. Now, if we want to find the accumulated function graph, which is our middle figure here, what we need to do from that first figure, this is what we want to do, and we want to go from our first figure to our accumulation graph. We need to add in these little boxes here on the right graph. So if we add all these little boxes in, that's going to help us estimate the area. It's still going to be not precise. It's going to be, inexact, but it's going to help us get at least a little bit closer. Now, if we think about this, each of these boxes, it's 4 by 2, so they're actually 8 million cubic feet per million cubic feet, I should say. And if we cut it in half, then it's going to be, to 2 hours, and that's going to be 4 million cubic feet. And if we cut that in half again, that would be 2 million cubic feet. So depending on how we want to look at it, we can, split it apart in different ways. Now, what we're going to do is we're going to actually do this curve on the next page here. And we're going to split it in just half. So we're going to go by 2's. And so looking at our first one here, we have from 0 to 2. So we're doing this first integral. And we're going to have, 2, 4. And that's not quite, here would be 1. And so I'm thinking it's about, it's, like it says, 4.75. So we're going to take each one of these is worth 2 times that 4.75. We get 9.5 million cubic feet. Now, if we look at the light blue, we're going from 2 to 4. And so then we have 2 and then almost 4 there, plus a little bit more. So we're going to say it's about 4 1/4. So multiply those together, we get about 8.5 million cubic feet. Now, what we're going to do is take this information now and plug it into a table. So we're looking at the interval from A to B. So first one we did from 0 to 2, the second one from 2 to 4. And so from 0 to 2, we found it was 9.5 million cubic feet. And so our accumulated area at that point in time is 9.5. Then we went to 2 to 4, and we found it was 8.5. So we add 8.5 to our 9.5, and we get our 18 million cubic feet for the accumulated area. Now, how does that work? Well, what we're going to do is if we go back here, at 0, we had 0. Then we went to 2 and we had the 9.5. Then we went to 4 and we had the 18. And we're just going to keep doing that as we move across all of our graph, basically. So then we'll do the next 2. So here we go from here and here. That's going to be 2, and it's a little bit more, maybe 3.5 or so. And so that's going to give us our 7. And this is going to be 2, and it's going to be about maybe 3, they say. So we'll accept that as 3. That's fine. So we have a 7 and a 6. So now from 4 to 6, we got a 7. And from 6 to 8, we got 6. So we had 7 plus 18, we get our 25. Add 6 more, we get our 31. And we're going to just continue to do that as we move across our graph. And so until we get to that very end, and then we get our last one from 24 to 26, we have 2, 4, 6, and yeah, it's probably about 6. So we'll call it that. And so then our 26 to 28, we got 2, 4, 6, and that's probably about 7, like they say. And so we get 12 on one, 14 on the other. We add that to the previous ones, so we're up to 110.4. And so we look at that on our graph. That's these last 2. So, we're at the 96.4 here. We move up to that 110.4 here. And now we've got our total accumulation graph. Okay, so that's how we're going to work these. So, they give us something like this. We have to add in the boxes, or they'll do it for most of the assignments. And then after that, we can make our accumulation graph based on that. Okay. All right, so let's stop there, and then we'll come back for some more.